right, let me get you a note packet. You shouldn't need your book for the next couple of days. Thursday, Friday this week, and then next week. Should not. Get an extra one. Please put your name on this note packet. I only print like one extra, so if you all lose it, you're gonna have to go online and print it yourself. Can't keep losing stuff. All right, after you put your name on it, let's just glance through it real briefly. Today is 12-1 notes. That will be the front and the back of the first page. You'll see your homework is in the packet. That's the following page. We have 12-2 notes, front and back of that page. Then you'll notice we're skipping activity 13. So we're doing activity 12, skipping activity 13, and there's only one lesson from activity 14. We're doing activity 14-2. At the end of your packet is a fairly long review for your test. Several days away. I can actually tell you the test date if you want to write this at the top. Our test this year is going to be Tuesday, November 16th, if you want to write that down. Tuesday, November 16th is the day I have projected for our test. So just be aware that you have the review right now. It is 4 pages, or 2 pages front and back, however you want to think about it. As you look through it, you might know how to do some of it right now. Thank you. Because you've already done activity 11. And this covers activity 11, 12, nothing in 13, and one lesson in 14. So let's get started on the first page of notes. If you will flip to the very front, you'll see this. 12-1, example A. If the following is proven, what else can you prove? So let's say you've done a proof and it says, prove the triangles are congruent, and here they are. You know triangle ABC is congruent, exactly the same size and shape as this triangle. Because it's written in this specific order, that's telling you a bunch of things. I'll get you started, and then I'd like you to help me figure out what else it's telling you. Because I know these triangles are congruent and it's listed like this, I know, write this down, angle A is congruent to angle G. A is listed first. G is listed first. They're what we call corresponding parts. They're in the same place. Please take a wild guess at what else you think you could prove besides just angle A. Are there any other angles you could list? Think about that and write them down. Bryce, did you come up with something?
Yeah.
What'd you put? Very good. Angle B congruent to angle H. Notice I have the angle symbol in front. Angle B, not just the letter B. Angles are always 1 letter or 3, but never 2. Hannah, what else do you have?
Angle C is congruent to angle K.
Very good. Did anybody have anything else besides listing 3 angles that are alike? Okay, let me get you, Toby.
Line AB is congruent to line BH.
AB, I'm going to say segment, but you're kind of on the right idea. Lines just go forever. So I'm going to say segment. AB, so first 2 letters. What did you say that's congruent to? AB congruent to? Yes. All right, Toby got us started. See if you can write 2 more sides that would match up. Cameron, what else do you have? BC, middle last letter, congruent to HK, middle last letter. These are segments or sides, 2 letters always. Haley, did I already pick on Haley? Did I already ask you? Go ahead, Haley. What else? Do you have another one?
AC is congruent to GK.
Yes, AC congruent to GK. I could have said CA or AC. It doesn't matter. A side has 2, so it doesn't matter what you list first. Somewhere up by this, I'd like you to write this down. Write down. These are corresponding parts. These are corresponding parts. First letter, those are corresponding. Middle letter, those are corresponding. So these are 6 sets of corresponding parts of congruent triangles. There's going to be this shorthand phrase you see today. You don't have to memorize it. It will just save you time. It makes it shorter. And it says this, CPCTC. Let me tell you what that stands for. You don't have to memorize it if you don't want to. C stands for corresponding, and then P, parts. CP, corresponding parts. Then there's the word of. Of usually doesn't get its own letter, so I'm just going to put of right here. Corresponding parts of. Anybody guess what the CT stands for? Yes? Congruent. Yeah, we already wrote it. These are corresponding parts of congruent triangles. CPCT, corresponding parts of congruent triangles. You already know what that means. You've done it 6 times. You found the corresponding parts, the parts that go together. And where are they from? They're from 2 triangles that are congruent. What's this last one? Well, if C and K are corresponding parts, are they the same? Yeah. If angle H and angle B are corresponding parts, are they the same? Yeah. Every set of corresponding parts are congruent. So that's what this stands for. Corresponding parts of congruent triangles are congruent. Just like if you were to go to the car dealership and buy a 2022 Honda Civic, and there was one Honda Civic here and one Honda Civic here. Are they going to have the same engine? Assuming we buy the same car, same year. Yeah. Are they going to have the same windshield? Are they going to have the same buttons on the dash? Are they going to have the same seats? That's what we're talking about here. We have 2 triangles that are alike. We have 2 cars that are exactly the same. Every single part of the car, every single part of the triangle are the same. Are all the angles equal to each other? No. But an angle here matches an angle here. An angle here matches there, etc. So corresponding parts of congruent triangles are congruent. You can write that out in a sentence, or you can memorize the sort of abbreviation, CPCTC. Let's look at our first proof. It says, use the given information to prove the parts of the kite are congruent with a flow proof. You can cross out flow proof for right now. We're not going to do a flow proof yet. We're going to do an old 2-column proof. Notice I left the proof part blank on purpose. let's just draw our two columns and I'll tell you where to start. I want you to prove the triangles are congruent. I just didn't list that yet. So we're going to prove the triangles are congruent. Let's start where we always do with the givens. Okay, so these are not direct statements. We're going to have to figure out what they're trying to say. It has two parts. GK bisects this, and it bisects this angle. Let's start with one at a time. I'm going to use a highlighter, and I'm going to highlight this angle, FGH. Look at it in your picture so you have it before I draw it. Angle FGH. Here it is, F to G to H. I know that that angle is being bisected by this line. So here's my question for you. If something's cut into two equal parts, according to my picture, do I have two sides alike or two angles alike? What do you guys think? With the words in the pictures, the question is, do I have two sides that are alike or two angles that are alike? What do you think? Yeah. This angle was cut into two. So let's go ahead and let's just put a little 1 and a 2 here to save ourselves some time. And let's mark those alike. Let's write down here definition of bisect. What did this bisect tell us? It told us what Lucas said here, that these two angles match. They're alike, congruent, equal, all those things. So over here I'll say angle 1 is congruent to angle 2. So that sort of takes care of this given. I was bisecting an angle. I happen to also bisect another angle. It says I'm also bisecting angle FKH. Find that, FKH. I'll find it up here, F to K to H. You should see, oh, I have another large angle bisected, cut into two. So this big angle is cut into two equal angles. These angles must be alike. Let's call those 3 and 4. Mark them alike. I have to put 2 little arcs on them. Write down what would go in your proof. Trevor, what'd you write in your proof? Very good. And how do you know 3 was congruent to 4? Huh? Same reason as up here, right? That angle is cut into 2. We have another angle cut into 2. So it's the same reason. Definition of bisect. Okay, look at my triangles. Are they congruent yet? Shake your head. Yes or no? Are they congruent? They have two angles in common. AA is not enough. But there's nothing else in my given. Sage, you see anything else in the picture that we commonly mark and see? You're close. What?
I don't know how to pronounce it.
Braided? Reflective. Yep. So that's this overlapping side.
I was thinking of a type of ghost. for some reason.
Oh, yeah, way off then. I thought you were right on. Starting with the right letter. So we're going to write reflexive.
Is that, I got mixed up with a ghost.
I don't know what you're talking about.
Revenant type of ghost.
Oh, gotcha. Brayden, what do I write over here for reflexive? You know? Okay, so what side is overlapping what side? Ooh, those are angles. We have, Tessa, what do you think? Yeah, GK of this triangle matches side GK of that triangle. So we write GK congruent to GK. Reflexive is an overlap, so it'll always be the same side listed. Are the triangles congruent? Yes. Triangle. Let's name the top triangle KFG. I can name the first triangle any way I want to. But look up here. Do you guys understand the importance of the order in this statement? If it's not right, things aren't going to line up. So you can do this any order you want, but this has to match it. So let's see what goes with what. You just have to look at your picture and figure it out. Here's how I would do it. Look at angle K in your picture. Hey, angle K is right here. We're looking at this top triangle. K had this little double mark on the arc, the angle. Hey, so does K down here. So that must go with K again. Next, I listed F. F is the only angle in this triangle that doesn't have a mark. Hey, H is the only angle that doesn't have a mark in the angle. So they have to go together. And hopefully the last one left goes with the last one, which it does. Just so you know, if both triangles have a K, they won't always be in the same place. I say, how does that work? We might get to one, but just so you know, if I have a K and I have a K in this triangle, they won't always be listed in the same spot. Okay, write down how you know they're congruent. Which of the 5 methods prove they're congruent? I see 2 angles. And this side is touching both of those. So ASA. Now that's nothing new. That's something we did in activity 11. Activity 12 just goes one step farther. I'm going to have you fill in this proof statement, and we're actually not proving this. I just wanted you to start there. I want you to prove that side FG is congruent to side HG. Well, let's look at our picture. Here's FG and here's HG. I can't mark those. Those aren't vertical angles. Those aren't reflexive. Those aren't right angles. I don't know those are congruent. But look at what we just did. Just like in the first problem, when we did this, we have one of those right now. Where is FG. Right there. What will FG have to be congruent to? HG, right? How do you know that those are congruent? Well, because they're corresponding parts in congruent triangles. That's why they're congruent. They're in the same spot. So FG must be congruent to HG. For the same reason that you did this 6 times. They're corresponding, they're in the same place, so they've got to be congruent. So I'm going to write they are corresponding parts of congruent triangles. They are corresponding parts of congruent triangles. If you don't want to write that, you can write right here, C, T, C, T, C. The last C stands for they're congruent, which you wrote on this side. If you're not going to remember CPCTC, you don't like one more thing to memorize, you can just write it out in words. They're corresponding parts of congruent triangles. All righty. Notice we could not have done this last step if we didn't have this first. So you prove the triangles are congruent, just like you did on your last quiz. And then you find the parts that correspond. Let's try example, says D. We are proving 2 sides are congruent. In your head, tell yourself, I'm going to prove the triangles are congruent first. And then I'm going to pick, hopefully, those sides that match up. So we're trying to get this first. Once we have congruent triangles, then hopefully they land in the same place and they're corresponding. We are going to try what's called a flow proof. It's just a different way to write it instead of 2 columns. You will probably be required to do 1 flow proof. It's the exact same wording and phrases. It's just organized differently. Some of you who are good at art may like this method better. It's a little more flowy than just sentences or more phrases. So here's how it works. Sorry if you already drew your 2 columns. Thanks for getting ahead. Let's go ahead and write the first given, EB congruent to EC given. It's going to kind of be in little bubbles. You're only going to do 1 given at a time. Let's find it in our picture. EB is the same as EC. Let's put the next given in another bubble over here. Now, that's not a direct statement like this was nice and direct aside. This is a hint. So what are they trying to tell me? E is the middle of AD. So here's E. Let me highlight AD. Yeah.
It's saying that it's the middle of
Right. It's saying that this is congruent to this. It's one segment with a middle. The sides have to be alike. Very good. Oopsies. So let's mark that. Now, because that statement that Tessa just said, that these are like stems from this, we're going to write it below. So we're going to say, because of this statement, because of midpoint, I was able to figure out something else. And that's what Tessa told us, that AE was congruent to ED. Because of midpoint, I was able to say these are congruent. I do have to put my reason below, so I kind of just write it again. Definition of midpoint. So we've done this given, we've done this given. We're out of givens. Lily, you see something in our picture that we should talk about? Please mark vertical angles. Lily, did you say vertical angles because of either of these givens? Does it relate at all to those givens? No, it gets its own bubble. Don't connect it. Just say in your own bubble, angle 1 congruent to angle 2, vertical. Do we think the triangles are now congruent? Does it look like we have enough information? Yeah. So I cover this one up. I see 2 S's and an angle. So I'm going to write triangle. Kenneth, name the first triangle for me on the left, any way you want.
A, B, and B.
A, B, E. He says A, B, E, I think is what he said. So we have to name the triangle on the right in the same order. We haven't had much practice at this, so follow along with me. A is first. Here's A. Well, darn, there's no little markings in there. What is A close to, or what's next to it? A has a side with no marks and a side with 2 tick marks. So I'm looking over here at what other angle also is touching no tick marks and 2 tick marks. Is that C? No tick marks, 1. Is that D? Yes, no tick marks, 2. So you just have to slow down and figure out what matches. Angle A matches angle D. Next, we listed B. B is touching no tick marks and 1. That goes with C, no tick marks and 1. So C is listed next. And finally, E was our vertical angle, and that matches perfectly with E over there. Put that in a bubble. What's my reason for saying the triangles are congruent, Anthony? SSS, SAS, ASA. What do we have 2 of? Is the angle in the middle touching both of those sides? Yes. So 2 S's with an A in the middle. Let's look at our diagram. Does this statement that the triangles are congruent, did I need this statement to say that? Don't I have 3 statements that came together to say this? I needed this statement that that side was congruent. I needed this statement that said those sides were congruent. And I needed this statement that said those angles are congruent. If I have side, angle, side, then there are 3 statements that got me to that conclusion. So I connect this one, and this one, and this one. Again, if you like flow proofs, great. You can do them all the time. If you don't, you prefer that 2-column that you're used to, I think I'm only going to require flow proof one time in the rest of the semester. Questions on the organization? We have one step left. Does anybody already know they like it? 1, 2, so far 3. Okay, I kind of like them. Here's why we're not quite done yet. We did a good job of proving the triangles are congruent, but we're asked to prove AB congruent to DC. Let's find AB. Here's A, here's B. Is that in the same place as D and C? Yeah. So, because of this statement, I can say those corresponding parts are equal. AB congruent to DC. My reason, they are corresponding parts in congruent triangles. I can write that out in words. They are corresponding parts in congruent triangles. Or I can write CPCTC. Okay, we only have one left. Let's try a flow proof just for a little more practice. Let's start with one given at a time. AH perpendicular to MT given. Unfortunately, that's not our favorite given. That's trying to tell us something. We have to figure out what it's telling us. And we talked about this yesterday. What is it telling me if AH is perpendicular to MT? Who can tell me? Yeah. Ooh, not quite. They're not the same length. So if I have this, and they're perpendicular, that doesn't necessarily mean they're the same length. What do you think? Yeah, perpendicular, no matter how long these are always right angles. Perpendicular makes 4 right angles. So let's go ahead and put in your diagram, put a 1 and a 2 and mark that they are both right angles. So it stems from this statement. Because they're perpendicular, angle 1 and angle 2 are right angles. How did we know that? Definition of perpendicular. We got the hardest part out of the way. Let's go ahead and write our other given. Mark it in your picture. Angela, is there something else you see in the picture that happens a lot? Kennedy, what do you think? Yeah, let's mark reflexive and let's write it. Reflexive. That was side AH from this triangle and AH from that triangle. Okay, let me cover up one triangle. Looks like I have enough. I have two red sides, and I have this angle. Is this blue angle touching both red sides? No. Are we allowed to have an angle touching just one? So don't try to put them together to say angle side side. Is it a right triangle? Have I written that I have right angles or right triangles? Good. Does the hypotenuse have a mark on it? Yes. Have I written it? Yes. Does another leg have a mark? Just did it. Those three together say the triangles are congruent by HL. HL, right angle, hypotenuse, and leg come together. Caitlin, name the first triangle, please. AMH. All right, everyone. See if you can do the order for the next one. A actually does go with A because A in this triangle is by the single and double arc and single and double. So A goes with A. M has no marks and T has no marks. H is the right angle and H is the right angle. There's another flow proof that proves the triangles are congruent. Does it say prove the triangles are congruent? No. It says prove that H is the middle point of MT. We want this to be the middle. Well, we don't even know these are congruent. But let's look. Is MH in the same place as TH? So do we actually know these are congruent now? We do. So below this, let's write MH is congruent to TH. How did I know they're congruent? They're right here. They're corresponding parts of these congruent triangles. CPCTC, corresponding parts of congruent triangles are congruent. Okay, so in your picture, now you're allowed to mark these alike. Only because you've already proved the triangles are congruent. So all the parts match. Now, is H the middle point according to my picture? It has to be if these match. So let's write, because of this statement, H is the midpoint of MT. How did I know it's the middle? You can kind of write this in your own kind of freehand way. Something like, how do I know it's the middle? It's divided into two congruent segments. H divides MT into two congruent segments. Let's look at your homework. Your homework has 5. I don't want to make you do 5. I want the ones you do to be really good, and I don't want 5 to be too overwhelming. So let's just do 1 through 4. Keep 5 in case we have time to do it in class, but you do not have to do number 5 for homework. You need to do a flow proof for 2 of the problems. You can do 2 of them as 2 columns, 2 as flow proofs. If you like flow proofs, you can do all of them as flow proofs. If you hate flow proofs, you have to do at least 2 of the 4 as a flow proof. You can pick which 2. Any questions on that? What your homework is? All right, good job taking notes. You do not have to work on this now. There's not too many minutes left. 7 minutes. You can be on your phones.